And now we're going to go to the rotor construction and design of it. Here's one rotor on a shaft right now with bearings on each end. Here's a close-up. This is 1 1/8 inch steel shaft, threaded. I got some bearings that fit on there, steel bearings. And I cut a groove with a power saw and a metal blade down here, and I embedded this, I cut it from some steel, so it's about 3/16 inch thick. And also I used some JB weld too and clamped it overnight, hold it in that groove I cut. So I'm going to have 3 rotors on this shaft. Here's one rotor so far. I have 1/4 by 20 stainless steel bolts holding the hubs on. Goes all the way through, and I use some Loctite. Make sure those nuts don't come off. And see, also I cut a groove in the hub all the way through. So I guess you can call this a key, and the slot would be a keyway. And so this is one of the rotors on there already. And here's the back bearing. I also put some 24-hour JB weld on these, just so there's not going to be any rattle or anything. It's important that this rotor spins really flat. And I actually did a pretty good job with it. See the little gap right here? It doesn't look too bad. This long key I put in makes it so it's pretty off balance now too, so I'll have to rebalance it when it's all together. See, it always settles down with that down. It's going to have a length about this long sticking out one end of the motor, and just a stub axle sticking out the other end. This is going to have like the timing disc on it, and this is actually going to be connected to the transmission of the motor or whatever it's going to be powering. Okay, this is going to be the central rotor. It's going to go in the middle here, and it's very important that you orient these magnets right. They're all facing one direction in the rotor. So take like a magnet, another magnet, push it. So that's north against north right now. You can feel the push. If I go the other side, it'll attract. See that? So right now, let's say this is north, push. So now when you take this rotor, you want to make sure that the pull side, not the push side, it's pushing on that side, it's pulling on this side. So you want pull on one side, push on the other. Because when you put that coil in between, about 3-inch long coil in between here, when you energize that coil, it's going to be north on one side, south on the other. So you want also north on one side, south on the other with the rotor magnets. Also, you're going to want those rotor magnets all exactly in line when you have the 3 rotors, all exactly in line. So I put a little mark right here, which is the center of that rotor magnet. And so this is like, let's call this top dead center. Now the next rotor I put on, we also want that center of that, exact center of that magnet to be exactly straight up, just like this one, so that everything's lined up.